All right, well, as you just heard, this is an endeavour to look at the state of play with an existing cohort study, the British Cohort Study 1970, in which the cohort members who are still with the study in the ripe old age of 45 now. And the motivation largely for this presentation is making a case for the incorporation of a strategy to handle missingness. And whilst I appreciate the massive efforts that go into the field, and as Lisa was just conveying, things have got so complex now with respect to people's expectations, the various modes that are being used to obtain cooperation or collect data. But at the end of the day, we're facing a scenario where there's this pervasive challenge that is of non-response or unit non-response, as was so adequately described earlier. But in addition, the fact that some participants cooperate but don't provide all item responses. So we have to deal with item non-response as well. So let's so in terms of the presentation then, I want to begin by looking at the impact of attrition in the British Cohorts survey and look at potential remedy for addressing that attrition, and then to illustrate and evaluate the use of non-response weights or inverse probability weights in conjunction with multiple imputation techniques. I don't need to tell you probably that the British Cohort Study now there are 9 sweeps of data commencing in 1970. It's a multi-purpose longitudinal survey in a few words. And I'll be talking about or presenting you with a single case study of an analysis based on sweeps 3 and 4. Perhaps we should just pause a moment in terms of attrition. Is a word that has an import. It's the discontinued participation of a cohort member in the study. But as we heard earlier, some participants will be missing for a sweep or so and then return to the study, often due to the hard labour that field agencies have put in to persuade them to return to the study or a change in their circumstances. So attrition is a sort of moving target. But in terms of the methodological literature, we can identify good cooperating cohort members as those who furnish a response at every sweep. They're the loyal brigade. So we describe those as the first pattern of participation, and the second patterns refer to those individuals who, once they've left the survey, they don't return. They refer to in the literature as exhibiting a monotone response pattern. And the second 2 examples in that slide illustrate the perverse individuals, perhaps, who are there for some of the time, go missing, come back. They're non-monotone. How do these patterns represent themselves in the British Cohort Study? Well, if you look at the bottom table, 27% of the participants of the original survey represent a monotone pattern of response. But an amazing 53% fall into this non-monotone category. And it's that loyal 20% who have responses for every single sweep, as at age 42. So I would appeal to you that if we proceed in our longitudinal research and simply condition on the loyal 20%, we're losing an awful lot of information. And I'm a pragmatist who would argue that if we have information and we can use it, let's use it, but let's use it scientifically or pragmatically. Okay, just a couple of words of theory. We've seen since the 1990s an emergence of multiple imputation methodology, and I'm not going to go into very much detail today. But also, the old survey methodology tradition, which I was raised on, was the use of inverse probability weights to adjust for those who attrit. But the issue is the application of IPWs, as I'll call them, will ignore or will not furnish any further information about individuals who have patterns of item non-response. So we're going to look at the use, or I'm going to illustrate the use of both methodologies, alone and in combination. And a lot of the work you'll find tremendous surge in the literature. For those of you who are feeling nervous and about to embark on some longitudinal research, I would recommend, this is a sort of commercial break, a chapter treatment by Carpenter and Plewis in this lovely Sage book. And also, if you really want to get into multiple imputation, Carpenter and Kenwood's book, which is a whole book dedicated to the methodologies. But the majority of multiple imputation or multiple imputation depends on making sets of assumptions about the missingness, the process of missingness. And these are the familiar trio of assumptions which drive our remedies. Missing completely at random, where the absence of information has no relationship to the characteristics of the individual. Missing at random, where the missingness has a direct relationship to the characteristics or a relationship to the characteristics of the individual. And finally, a missing item of information or items which are in a sense related to variables or characteristics that have not been observed. So it's a mysterious process as to what's driving the missingness. Right, returning to the case study, here we can see the overall response rates for BCS 70 cohort members. Sweep 4 is the year when cohort members were age 16, coinciding with a teacher's strike and some fall off. And then between Sweep 4 and Sweep 5 was a 10-year lapse, and also the collection or the responsibility for the provision of the data went from the parent to the cohort member. So you can see a drop there to 65% to 50%. It's also confounded by a change in the mode of data collection, something else to be juggling in your thinking of the response process, and then a flattening off over to Sweep 9. But that is those response rates are the wave-specific response rates. So they'll pick up returners, if you like, and they will look a little bit more optimistic than if we just focus on those who are in the sweeps for every single observation, the 20%. Okay, so what impact does this drop-off reflect? Now, what we have in the BCS 70 and in most longitudinal surveys are some birth cohort surveys. We have some benchline basic data appertaining to the cohort member at birth, and we've got that data for almost every cohort member. So we can have a look at the impact of non-response or attrition over time in terms of dad's social class, when mum finished for full-time education, whether mum was a single parent at birth, whether mother was living in London or not, whether the number of pregnancies mum had recorded. Gender there, if you're perplexed, means the gender of the cohort member, not the parent. Okay, there's three. I'll just show these examples. You can see a falling off in the proportion of men in the study by Sweep 9, falling off in the proportion of fathers in manual social class position, a fairly flat, that's the blue line, that's fairly flat, but it's still a falling off. And then mother's age of finishing education at 15 is also falling off. Again, here we can see falling off in terms of number of single parents, although mothers who are single parents at birth of the cohort member, picking up in later sweeps, whether or not mum lived in London at the time of birth, and whether or not mother had 3 or more pregnancies prior to the birth of the child. Okay, we can model these characteristics because although we might report individual, the proportion of individuals with those birth characteristics when the cohort member is age 42, what happens if you combine the effect of these individuals on the probability of obtaining a response in any wave? So we ran a series of binary logistic regressions using these birth characteristics for each sweep. And here's the present that I've prepared for you. In that when I said I wasn't going to present any numbers, that was a bit of an exaggeration. But there are lots of numbers in a set of complementary slides. So I'm just taking out the main or tentative conclusions. If you simply try and predict the probability of response for a particular sweep, then using all of these birth characteristics, the goodness of fit, or the R squared, is very, very tiny, between 2.5% and 3.5% over time. But you can draw some indicative conclusions, and they probably won't surprise you. In the paragraph, I tried to sum up, women are more likely to respond than men. Cohort members born to single-parent mums, less likely to respond as cohort members who have 2 parents at birth. There's an impact of not breastfeeding, having older siblings. If mum is slightly older than the majority of mums at the birth of a cohort member, and mums had a longer formal education than the majority of mums, then cohort members are more likely to respond. So you can see a kind of combination of factors which are generating a bias which is more complex than if you simply isolate one of these factors on its own. Now, if you construct a probability weight from these logistic regressions, which is a standard practice in the Millennium Cohort study, using probability weights, not quite the same way as this, I must add, but the weights can recover some of the selection bias for later sweeps. Now, here's an example of the percentage estimates of mothers who were living in London at the time their child was born in 1970. By the time they got to sweep 4, at birth there was about 12.5% of mums were in that situation. If you return to the cohort members who remain in the study at sweep 4, you'll see that point estimates drop to 9.5. If you apply the weights based on the response and the birth characteristics, you recover that point estimate. So depending what you're applying the inverse probability weight to, you can recover a lot of the lost information or the representativeness, or you can in some sense recover the underlying representativeness of the study. But it isn't a panacea. It just happens to work in this instance. Okay, so what about if we want to sort of belt and braces approach and apply multiple imputation to these data? Our multiple imputation techniques all depend on missing at random, and typically you generate several replications of filled-in data, and the parameter estimates are obtained by averaging across the replications of your analyses. And variance estimates are combined using Rubin's rules. So that it's a fairly good set of routines now in packages like STATA, which allow you to modify your filling in process according to the type of data. So according to levels of measurement, assumptions, nominal, ordinal, or continuous. And for those of you, again, I'd recommend Kenwood and Carpenter. So my argument rests on an argument that was made by Colton and Lepolsky going back to 1980s. So 1980 saw the beginning of people thinking about applying multiple imputation. I think multiple imputation methodology took off in the 90s, and Colton and Lepowski were advocating then a combination of use of probability weights, inverse probability weights, and multiple imputation. But their argument is very strongly that we need to know more about the response process. That's what I can't give you in this talk. That's what Lisa will need to give us. So we need, there's so many challenges in terms of what's driving lack of cooperation that we need a lot more kind of research as to what characteristics drive the non-response process. I'm going to try and illustrate that with a single case study taken from BCS 70, where we're modelling vocabulary scores age 16 in terms of gender, the gross family income of the family when the child was aged 10, and the highest parental qualification aged recorded at sweep 16. We're going to construct inverse probability weights for the sweep 4, and we're constructing a hypothetical scenario. So we're going to take what data we've got available at sweep 4. If we condition on those respondents who have complete data for our substantive model, we're then going to impose a pattern of missingness on that sample. We're going to deduce 10% missing completely at random on the outcome, and then condition on social class so that 40% of the respondents are missing on income and their highest education qualification if the respondent had a father who was in the manual social class, and 10% if not. And then we don't knock out anybody's gender in this analysis. So that's how we construct our case study. The stages, if you like, from the original sample, sweep 1, over 15,000. Some people think, oh, he's lost 2,000 cases. Well, there are a number of individuals who didn't have complete birth characteristics. By the time sweep 4, there were 10,000 cohort members in the study. If you condition on those cohort members who had complete data for my hypothetical substantive example, that drops to 4,000 or so, but that's complete for those variables, and then we impose a missingness pattern, a distinct missingness pattern on C, and I've called it C miss. And then if we do a listwise deletion on that group, we come down to a sample of 2,000, or just under 2,000. So there's an intervening period, reduction between C and D. Okay, now we fit 6 scenarios. We use, well, no, not quite. Yeah, we do 6 scenarios. We have what I've called a model. Now, the word model is used in the broadest sense. The model is always the same substantive model. We're always modeling the literacy score in terms of the variables I described earlier, but then we're varying whether we use weights in combination with multiple imputation or not, or both together. Okay, so just think of these then as strategies or scenarios rather than models. The complete data uses the weights for sweep 4 adjustment for attrition. So that's called a benchmarker. Then we run the same model with no adjustment for weights. By line 3, we're using the complete cases for the pattern of the subsample for which there was missingness. So I've called that days gone by. That's what we all used to do. Listwise deletion. Don't worry about all the information we've lost. We just carry on and present our results based on the complete cases, days gone by. Fourthly, as days gone by, but with the addition of a weight. The weights. The 1990s model is to use MI on its own. The preferred resurrected model is to use both weights in conjunction with MI. Okay. For those of you interested in procedures in STATA, they're described, and I believe all the slides are available to you. So because of the shortage of time, I'm just going to say these MI procedures were applied using STATA. And what do the models convey? Okay. Well, models 3 and 4, the ones based on the complete cases, case D in my diagram, were least reliable, largely because you've lost a lot of sample members, so the standard errors are going to be larger anyway, but the parameter estimates don't match up very closely with the benchmark parameter estimates. If anybody can tell me of a good way of conducting a holistic comparison of parameter estimates in conjunction with their standard errors when you're comparing one model with another, I'd really, really appreciate that. As we'd hope, the preferred model and its version without a weight were the best performing models, but it wasn't they weren't mapping on to the benchmark model. So we return a mixed picture. It's not, this is not a foolproof, this is not the gold standard, but it's certainly an improvement on listwise deletion or using weights alone. So just to sum up, this is the model 2 not using the weights didn't have much impact. Well, that's not a surprise, is it? Because the weights, the regression models for the birth characteristics have very little explanatory power of non-response. Case-wise deletion, not reliable. With weights, no more reliable. Multiple imputation on its own, closest to the benchmark, but we get a dilution in the impact of having a parent with a high a high level of completed education on child's vocabulary, which could be intuitively. I think I could make an attempt at giving a narrative as to why that happens. Okay, and so that's where we go. So in conclusion, you cannot ignore non-response. And non-response can be partial, and if it's partial, we should be using that information. We need to know a lot more about the process of non-response, what generates non-response. I would recommend the construction of non-response weights to be used in conjunction with multiple imputation, but the selection of variables that go into the construction of weights needs to be informed by the process. So what characteristics of the cohort members are driving this willingness to cooperate or not, statistically speaking. Okay. I think that's, and if only we had more time, Tariq, Mustafa and I, then we could do more full simulations, vary the levels of missingness for our example, and or use sensitivity analysis, for which there's an excellent example using NCDS by Carpenter and Plewis in a chapter in this first book I recommended, where you're embarking on Heckman procedures or joint modelling, where you're attempting to model simultaneously the probability of response alongside your substantive outcomes, and the residuals correlate and the parameter estimates are adjusted. The problem is finding variables which predict missingness which are unrelated to the substantive outcome. So that's a challenge again. But we need to do a lot more sensitivity analysis, in my opinion. I don't think it's enough to just apply multiple imputation or FIML, for those of you who are FIML people, without thinking more about the degrees of missingness in your data, without reflecting more about it, and not rushing to have quick fixes and then forget about it. Nobody enjoys having to deal with missing data. I wish I didn't have to. But as I said, it's a fact of life. There's a really good paper to acquire if you are setting out and you want a fuller account of all of the steps and procedures in this talk. And I think we can make that available easily, can't we? Yeah. And for those of you who want the slides and do really have a kind of a yen for more data, more numbers, There's some tables on response categories over time, the patterns of response, what the models of non-response revealed in terms of the birth characteristics, and finally what the hypothetical models with various strategies applied to the case study revealed as well. So, you know, all things like that, which I can never read when I come to a talk in this room. It's probably my age and combination of my deteriorating eyesight, but, you know, I think sometimes you just get lost. So, if I've inspired you at all, it would be to read the paper I just referenced alongside Ian Plewis's chapter to get started. Thank you.